Hassler here. I'm going to work through the 8.6 Explore and Notes. It says, what's the fastest growing city in America? So the U.S. Census data can be used to track which cities in the U.S. are growing the fastest. The city of Buckeye, Arizona has been on the list of fastest growing cities for several years due to its excellent winter weather, proximity to the job market of Phoenix, and convenient access to many outdoor activities. In 2010, the population in Buckeye, Arizona was 50,876 people. It is estimated that the city's population grows by about 6.5% annually. So it feels like we have some keywords in here, right? We have an initial population that we're starting with, 50,876 people, and I'm growing, so growth, by 6.5% annually. So approximate Buckeye's population in 2011. All right, so 6.5%. Well, I know I want to multiply this 6.5% by the 50,876, but if I'm looking at it in terms of a rate, I need to take the 6.5% out of percent form. So what I'm going to do is I'm going to say, okay, well, 6.5% divided by 100% would be 0.065. And so that is my rate. So I don't multiply by the percent as is. I need to turn it into a rate that I will multiply by. And so I need to take it out of percent form. Okay, so that means that now I can multiply that 50,876 by the 0.065. And when I do that, I get 3,306.94. Now, wouldn't it make sense to stop there because this number is way smaller than the 50,876 people. So what I need to do is I need to take that 3,306.94 and I need to add that on to the 50,876 to give me a total number of 54,182.94 people. Okay. So I really had to do like 3 steps, right? I had to turn the percent into a rate. I had to multiply the rate by the initial, and then I had to add that amount onto the initial. Whew, it's a lot of steps. All right, let's keep moving to see if we can decrease these steps in any way. 2 said, what was the difference in population between 2011 and 2010? Well, that difference in population was this number right here. So 3,306.94. How many times greater was the 2011 population than the 2010 population? Okay, I'm going to think about this in terms of a table, right? So we've got the 2010 population. Hello, there we go. And I've got the 2011 population. We said in 2010, I had 50,876. In 2011, we calculated 54,182.94. And so the question is asking, how many times greater? Like, what number do I multiply by? Do I multiply the 50,876 by to get 54,182.94? And the answer is not 0.065, because if I multiply that 50,876 by the 0.065, I get this number. Okay, so remember, if I want to find a common ratio, I can divide a term, 54,182.94, divide that by the previous, 50,876. And when I do that, I get 1.065. So it's interesting because I still have this 0.065. It's just that I have this additional 1 in play. And so I kind of want to explore a little bit to see, why is that? Okay, so let's come down here. We're going to complete the table. We're going to show our calculations. All right, so we said that to get the 2011, I want to show my calculations. So to get the 2011, we had to take the 50,876, and we had to add on whatever you get when you multiply 50,876 by 0.065. Now, I want to just pause for a second. I notice that I see this 50.876 twice. Okay? And the second one is being multiplied by this rate that was once a percent, 6.5%. And I really could think of this as being, I have 100% of what I started with. I have 100% of what I started with plus 6.5% of that value. Okay, and so really, this would convert, if I divide 100 by 100, I get 1. We said if we divide this by 100, we get 0.065. Okay, and so what it turns out to be is that what I'm really doing is I'm taking this 50,876 and I'm multiplying by 100% of what I have plus my rate of 1.065. Right? That's what we figured out up here. I'm going to multiply by that 1.065. And when I do that, type that in my calculator, I get the answer that we got above, 54,182.94. In fact, if that's my common ratio, I'm now going to take that 54,182.94 and I'm going to multiply by 1.065. 100% of what I have plus 6.5% of that. And when I do that calculation, I get 57,704.83. And I'm going to take that answer, 57,704.83, and I'm going to multiply by 1.065, and I get 61,455.65. Okay, what I notice now is that I have this break. I go from 2013 to 2022. This is 9-year difference, okay? And so if I want to find the population in 2022, I'm going to take that 61,455.65, and I'm going to multiply by that common ratio of 1.065, but I really should do that 9 times. Right? I'm going to multiply that for every year increase. Well, I don't really want to write this out 9 times. All right. And so I'm going to use that exponent to the 9th to indicate that I would have to multiply this 1.065 9 times to the population from 2013. And I would get 108,319.9. And so because this is the end, I will finally round this. If you round too early, then you'll get your answers will be off as you keep going. So you want to wait till the very end to do any rounding. Okay, it says, does the population of Buckeye, Arizona follow a linear pattern or an exponential pattern? And how do you know? It's going to follow an exponential pattern because I'm multiplying by this common ratio. See, I already have some information down below, so just stick with me here. It says, write an equation for P of T, the population of Buckeye, Arizona, T years after 2010. And so P of T equals my initial. We started out in 2010, so my initial would be my year 2010. That's my starting year. 50,876 times 1.065, because that was my common ratio, raised to the T. This is exponential. So this was a growth problem. I'm increasing by 6.5%. And so really, I started off up here. I started off by saying, okay, I first have to find 6.5% of 50,876. I then have to add that on to the 50,876. That was a lot of work. Right? And so that's what I ended up doing. Again, I ended up doing that here. That was 2 steps. Or I could have done just 1 step. And that 1 step is taking the 50,876 times 1.065, 100% of what I had to start with, plus 6.5% of that number. So when I have this growth, my number that I'm multiplying by is bigger than 1. What happens if I have a decay? So let's take a look at what I have down here. It says St. Louis, Missouri has seen a decline, so decay, in their population by about 2% per year. If this is the case, what would the decay factor be for their population? Okay, so in other words, I'm losing 2%. I'm losing 2%. And so if I'm losing 2%, then I want to know how much remains. How much of my population is left? Because we don't really look at I lost 2,000 people. We say, I have this many people, okay? And so if I lost 2%, that means I really have 98% of my population, okay? And so what we're doing here is we're saying, hey, I lost 2%, but that means that 98% is left. And so the growth factor is the number that you multiply by. And so again, I got to take that out of percent form. So 98 divided by 100 is really 0.98. That would be the factor that I would be multiplying by. And this seems reasonable because this number is less than 1. All right, so let's go to our quick notes here and talk about how oftentimes exponential growth and decay are given as percent problems. All right, and so let's see. I'm going to write exponential growth and decay are often given as percents. And so what I need to do is I need to rewrite as a decimal. I'm careful to say that though, because sometimes the percents are decimals. So I need to take out of percent form. Okay, so for example, if I have 3.2%, then to take it out of percent form, I'm going to do 3.2 divided by 100, which gives me 0.032. Okay, so I have to take this out of percent form so that I can get my rate. So this is going to be my growth rate. Either what I'm going to add to 1 or what I'm going to take away from 1 if it's a decay. So let's talk about that. Okay, so if I have exponential growth, I'm going to say EXP growth for sake of room, okay? If I have exponential growth, it means I'm going to have y equals a, that's familiar, b to the x. But with this percent growth, I have 100% of what I started with, so 1, plus whatever that r value is. And that r value is this growth rate, okay? And so this r value is that percent as a decimal. I'm going to say decimal in quotes because, again, sometimes percents are decimals. I'm just taking it out of percent form. So if I have growth, I'm going to say 1 plus that growth rate, okay? And if I have exponential decay, I'm going to have something similar. I've got y equals a, b to the x. But this time that b for decay would be 100% of what I have minus whatever my percent decrease is, okay? Now, this 1 plus or minus r really represents my b value. So again, b is 1 plus or minus that r value, and b is the growth factor. It's the number that I am multiplying by. Okay, so your job is to do problems 1, 2, and 3 on the Check Your Understanding and to work through the practice and to ask me questions.